Okay, students, for class 12, for class 12, relation and function, we already have discussed, given explanation for relation. Now today, function. So it is the continuation part of the first one for class 12. Now function. Function. First we will know what is the function. See, this is set A and this is set B. The element of set A is called X and the element of set B is called Y. Now what happens? Function means it is one algebraic expression where we put the value of X and we get the value of Y. So that is called a function. That algebraic expression is called the function. Now for the definition of function we will say, let A and B be two non-empty sets. Then a rule or method or correspondence F which associates to each element X belongs to A to a unique element f of X or Y belongs to B. Y belongs to B is called a function from A to B and is written as, we may write function which exists from A to B, set A to set B, we write it as f such that A to B. There is f is a function from A to B, or we also can write this as A to B, then here f. Here f of X is called image of X, while X is called the pre-image of f of X. Clear? When X belongs to A, Y belongs to B is equal to f of X, that is XY belongs to the function. Now domain, codomain and range of a function. Domain, codomain and range of a function. Now listen. Domain. The set A is called the domain of the function codomain, the set B is called the codomain of the function. And what is range? The set consisting of all images of the elements of the domain A is called the range of F. Thus we can say range of F of the function is equal to f of x such that x belongs to A, which is a subset of B. So we come to know that within range all the elements of the set B may come, may not come, may come, may not come. Now various types of functions, various types of functions. Various types of functions. First we will discuss many one function. Many one function. Now what is many one function? A function A to B is said to be many one if two or more than two elements in A, two or more than two elements in A have the same image in B, have the same image in B. Suppose this is A, this is B. Say this is 1, this is -1, and the function is f is equal to x squared. That is f of x is equal to x squared. Then for f of 1 you will get what? 1 square 1. For f of -1 you will get 1. So two or more than two elements have the same image in B. Therefore the function is many one function. Many one. Okay, more than one, many one function. Next we will discuss 1 or injective function. 1 number 2, 1 or injective function. 1 or injective function. A function f from A to B is said to be 1 if distinct elements means different elements. No two elements are same. Distinct elements in A have distinct images in B. If f is a 1 function, how to show a function is 1? If f is a 1 function, when f of x1 is equal to f of x2, implies x1 is equal to x2. Or we can also write f of x1 is not equal to f of x2 implies x1 is not equal to x2. So if a function is not 1, 1, then what is the type of the function? If a function is not 1, 1, then it is a many one function. Next, onto function. Onto function. Now, what is onto function? Onto function is also known as surjective function. Surjective function. So, onto or surjective function, a function f from a to b is said to be onto if every element in B has at least one pre-image in set A. It means there should not be any element in set B which does not have any pre-image in set A. F is onto. How to show? F is onto implies range of F is equal to B. Or we can say that if it is found that range of F and codomain is the same, because we know that elements of set B, it is called codomain. So range of F, if it is equal to codomain, then the function is said to be onto function. If a function is not onto, then it is an into function. If the function is not onto, then it is an into function. Then what is into function? So next, into function. Into function. Into function. A function f from the set A to B, from the set A to B is said to be into if there exists even a single element in B having no pre-image in set A. Clearly, if F is into, it implies range of F is a subset of B, proper subset of B. Range of the function will be a proper subset of B. Now bijective function. Bijective function. Bijective function. Bijective function. Now bijective function, A11 onto function is said to be bijective or 1-to-1 correspondence. That is, if a function is both injective and surjective, then it is called a bijective function. If a function is both on1 and on2 function, then it is called bijective function. Next, constant function. Constant function. Now what is constant function? A function f from a to b is called a constant function if every element of a has the same image in b. Then it is called the constant function. For constant function, the range of a constant function is a singleton set because it consists of only one element. Identity function. The function, next, identity function. Identity function. Identity function is denoted by IA. Identity function, the function IA, it is a function from set A to set A. IA belongs to IA of x is equal to x for all x belongs to A. IA of x is equal to x. That is, if we are putting x, we will get x for all x belongs to A. That is called the identity of the function. Domain of IA is equal to A and range of IA is equal to A. For identity function, domain is elements of set A and range of the function is equal to elements of set A. That is, we write domain of IA is equal to A and range of IA is equal to A. Equal functions. Two functions f and g. Equal functions. 8. Equal functions. Two functions f and g. F and g having the same domain D are said to be equal. That is, symbolically you can write f of x is equal to g of x for all x belongs to D. That is, equal functions means both the functions f of x and g of x are said to be equal if they have the same domain. Now, composition of functions. Composition of functions, it is very, very important. Composition of function. Now, what is composition of function? Let A, B and C be three non-empty sets, and let f is a function, from set A to set B, and G is a function from set B to set C. Like this. It is set A, set B, set C. F is a function from A to B. G is a function from B to C. Since F is a function from A to B, since F is a function from A to B, we can say for all x belongs to A, for all x belongs to A, there exists this symbol, there exists a unique element f of x belongs to B. So for x there is f of x. Again, since G is a function from B to C, therefore we can write for all f of x belongs to D, there exists for all f of x belongs to set B, there exists a unique element G of f of x belongs to C. Thus we can say for all x belongs to A, there is associated a unique element G of f of x belongs to set C. Thus we can define a new function from A to C. From A to C directly. Previously we have a relation from set A to set C via set B. Now this time we are avoiding set B, directly from set A to set C. So thus we can define a new function from A to C. This function is called the product or composite of f and g, of f and g, denoted by g of f. What is the variable? X. So g of f of x. Okay, g of f of x, and defined by, so what we get, g of f is a function which exists from A to C, that is g of f of x is equal to g of f of x for all x belongs to A. This is also known as function of a function. This is also known as function of a function. Okay, so this is up to for today. In our next video we will discuss, there is part 3, we will discuss on the topic inverse function. Inverse function and some very important proofs which generally come in board exam. Okay.